8.3 and 8.4 actually, because we're trying to get this part done so y'all could be done with trig. So in the previous section, we used law of sines to solve case 1 or case 2. In this section, we do the last two cases. And there's a bunch of word problems if we chose to do them, which I can pick from later if needed. Your objective is to be able to solve your problems. And again, these were case 1 and case 2, and that was law of sines. And now this is what we're doing here now, which is the law of cosines. Okay, so just like on the rest of chapter 8, make sure you're in degree mode. And a lot of this is historical, which I'm not going to read through. You can kind of read through it or skim through it yourself. Basically, it goes way back. Like law of sines was used in AD 150. Law of cosines was in Euclid's Elements, which is a famous book. Law of tangents is obsolete, so it's not used. Okay, and y'all can read through the rest. Now, there are many formulas with this. The main thing is this is going to be like the Pythagorean theorem for the first one, because it's like c squared equal a squared plus b squared minus 2 times those same side lengths, and it's cosine of 90. So this is when it's a right triangle. And as you may remember, at 90 degrees is 0, 1. So this whole thing turns into 0. So that's why Pythagorean theorem is just like it, if you have a 90-degree angle. Now, for ours, we're not going to really use 90-degree angles. And so we may have C as the longest side and angle C. We may have B, and then it's cosine B, and A and cosine A. Now notice how everything works. If it's B squared, it's going to have an A and a C for both of these. And if it's A squared equal, it's going to be a C and a B for both. Okay? So it says the square of one side equals the sum of the squares of the other two sides minus twice their product, and the cosine of the included angle, which is the angle between. So for example, let's just say we have an obtuse triangle. Let's just say this is C. That means this would be little a, this would be B. And so that'd be the top formula, where little c squared equal little a squared plus little b squared minus 2 times the product of those, and then cosine of this one. So that's what we're going to talk about. Now, let's just move on. You also have side, side, side. That's going to be a little different. That's when you're given 3 sides and you have to solve for the angle. Okay, so I'll show you all examples through that. Now, right after that, in the same assignment, we're doing 8.4 area of a triangle. And the basic one is just base times height divided by 2. But what if you have a side angle side where you don't have a height? Then you're going to have 2 sides and the sine of the angle. And then if it's side, 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 you're going to have a formula with square roots. And that's the worst one, just because there's so much calculator manipulation. So it's going to be called Hero or Heron's formula. Okay, so there's your basic formula. They just put K instead of A. Here's the one with side angle side. So like a half AB sine C, a half BC sine A, and a half AC sine B. So that's your area of side angle sides. And then the area of side, side, side is the one where it's going to look ugly. Like say, as an example, S equal 10, then your formula is going to be 10 and then 10 minus some number, 10 minus a different number, and 10 minus another different number. And usually you just do your calculations, like it could be 10 with 8, with 6, with 4, or whatever. Now, how you actually get what S is from this formula. You either use your half as a fraction or a 0.5. You add your side lengths and divide by 2. Don't add and divide by 3. You divide by 2. It's not an average. Okay, so that's your notes. Now, the first one is just a vocab type true-false question. And so it says a special case of the law of cosines is the Pythagorean. That's going to be true because we said cosine 90 equals 0. So that's going to be c squared equal a squared plus b squared. Okay, so that's just true. Now from here, we have to work our problem. So since these are side angle side in this one, I'll put SAS right there. That means there's no pair of information. So don't try to use law of sines. Law of sines would be like, say you know angle A and side A, or angle C and side C. Now, what I want to mention is when I put side angle side, don't let that confuse you, because this is the A, this is the B, and this is still angle C. I'll do it in capitals. Angle C is right there. Okay, so we have to use our formula. So if it's angle C, that means you use this formula, c squared equal a squared plus b squared minus 2ab cosine c. That's your formula. Now, your little a is 6 and your little b is 7. So we have c squared equal, little a was 6, so we have 6 squared plus 7 squared minus 2 times 6 times 7 cosine of 95. So that you just want to type in your calculator and make sure you're in degree mode. So 6 squared plus 7 squared, and I'm in radians, so I'm going to flip it there. 6 squared plus 7 squared minus 2 times 6 times 7 cosine 95. That gives me 92 something. Now, the most common mistake on these, at least to begin with, is don't forget your square root. So what I do is I type all that and then say square root of the answer. So in other words, in this case, square root of 92.32 with a lot of other decimals. Now, what you will see in a little bit is if you round early, it won't work. Okay? And so let's do square root of that, and we get 9.608. Now, we're rounding up to 9.61. Okay, now for this angle, it's not like you can like subtract from 180 yet. You can't do that until the end. So this was step one. Step two, we've got to figure out our angle. Now, if we're trying to find A, then you have to use the a squared formula. A squared equal b squared plus c squared minus 2bc cosine A. Now, if we are looking for the angle, the best method that I've discovered is we want to actually move this over to this side and move the a squared over to this side. So to do that, we have 2bc cosine A on the left, and we have b squared plus c squared minus a squared on the right. Now, we are still looking for cosine of A, and so we divide by 2bc. And now take the inverse cosine of that. B squared plus c squared minus a squared over 2bc. So this is a very important formula, almost as important as knowing what the others are. Okay, and then we just plug in our numbers. So we have cosine -1. B is 7, so 7 squared plus C we just discovered was 9.61. So 9.61 squared minus A is the 6. So 6 squared over 2 times 7 times 9.61. So that's a lot of math in one step. Make sure yours looks exactly like mine if you're doing it all in one step, because you might have to use extra parentheses. So for example, cosine -1, it's going to want inverse cosine of the whole thing, but we have a compound numerator, and so I need a set of parentheses. And then I've got to type 7 squared plus. Now here's where, when I worked this yesterday, I can't really use 9.61. Use the original. Use the original. I'll go ahead and fall into this trap just to demonstrate it. But you'll see 9.61 squared minus 6 squared. That's your entire numerator. And then your denominator needs to be 2 times 7 times 9.61. Okay, so when we do that, we get, well, that time it worked, of course. We get 38.458, which is 38.5. What would have been better is if we would have used the 9.608 with a bunch of decimals. Okay, but I know I saw that yesterday when I was working these. So anyway, all right. So that one's 38.45. So what I should have done is I should have said 0.8, whoops, 9 point, where is it there? 608, 608, 386, 04505. Okay, so when I do that, I get 38.468. And so this one will also go to 38.5. So I guess in this problem, it didn't matter too much, but anyway, we'll see. I can tell you when I worked this yesterday, that when I worked it with one way, I got 86.4, and with another way, I got 86.5. So that's the reason why. I'm not just trying to be difficult, but that's what you need to know, that sometimes it's going to be off a little bit unless you use the exact. Okay, so now we need to do the third angle. And don't, like for step 3, don't do 90 minus the angle. Most likely what y'all are going to do is say 95 plus 38.5 gives you 133.5, and then 180 minus 133.5 gives you 46.5. Most likely that's what you're going to do. You do that, or just say 180 minus 95 minus 38.5. You know, either of those approaches works. Okay, so that's problem 2. Now we have this other triangle over here. I'm just going to redraw it. Okay, so whereas that one was side angle side, this is side side side, because we know 3 sides. So you don't know any angles. So what we do for that is we do, well, if we're looking for A first, we do A squared equal B squared plus C squared minus 2BC cosine A. And if we do like that other one, we move it over and we solve, and we need to use cosine -1 B squared plus C squared minus A squared over 2BC. And now the other thing to remember is if this is where capital B is, the little b is the 5. I'm going to put 5 here. And then the little a is 12, and the little c is 8. Okay, so this is cosine -1, 5 squared plus 8 squared minus 12 squared over 2 times 5 times 8. Okay, so we need inverse cosine open another parentheses, go 5 squared plus 8 squared minus 12 squared divided by parentheses 2 times 5 times 8. And we need that, and we get 133.43, so that's 133.4 degrees. and so that's the A. Okay, now for the B, we do the B formula, and if you want to just shortcut it, I guess we can do that. We'll say cosine -1. Now notice when we did that, we had the other two. So in your case, we need a squared plus c squared, then minus b squared over 2ac. Okay, so let's work on that. Cos -1, 12 squared plus 8 squared minus 5 squared over 2 times 12 times 8. So I'm just going to press up twice and then change my numbers. So this one's going to change to a 12. This one's going to change to a 5. And this one's going to change to a 12. Okay, so we get 17.61. And so that's 17.6. Now that you have those two, then for your third step, you do 180 minus 133.4 minus 17.6. And that gives you 29. So then 29 is your answer. Okay, that's probably a good stopping place for the first video because it's already 22 minutes. Hope that helps. Have a good one.